In the beginning, there was light, or so we thought. But in truth, the story is far stranger. Light was never what it appeared to be. It shimmered, it bent, it interfered like waves on a vast cosmic ocean. Yet when it struck matter, it hit with the precision of a bullet. This is the tale of wave-particle duality. The story of how physics uncovered a secret so unsettling, it fractured the very meaning of reality. This is the moment science realized the universe does not behave, it performs. Centuries ago, people believed light was made of waves, vibrations in space like ripples in a pond. Others swore it was made of particles. Tiny sparks shot out like celestial arrows. Both sides argued. Both sides believed they were right. Neither could explain everything. Only later would we discover the truth. Light was not wave or particle. It was something in between, something deeper, something hidden. The year is 1801. A scientist named Thomas Young prepares a simple wooden board with two thin openings carved side by side, the double slits. He shines light toward them. If light were particles, it should create two bright lines on the wall behind. But what appears is something impossible. A pattern of many lines, bright and dark, evenly spaced, a wave pattern, an interference pattern. The room falls silent. Light behaves like a wave. The world changes, and yet, the universe has not revealed its full treachery. A century later, Albert Einstein studies a different mystery, the photoelectric effect. He discovers that when light hits metal, it knocks electrons loose. But this doesn't happen smoothly, like waves transferring energy. It happens in discrete packets, tiny hits, precise impacts, particles. Einstein names these quanta of light photons. And suddenly, humanity is left staring at an impossible paradox. Light acts like a wave, light acts like a particle, but never at the same time. This contradiction becomes the foundation of quantum mechanics, a world ruled not by certainty, but by possibility. Now the story shifts to the 1920s. Scientists begin asking a terrifying question. If light behaves like waves and particles, what about matter? They fire electrons, particles of matter, through Young's double slits. What emerges is unthinkable interference. Electrons form wave patterns. Matter behaves like a wave, a grain of sand, a speck of dust, a single electron. Everything has a wave nature, even you, even me, even the atoms that shape our thoughts. Every object, large or small, carries a hidden vibration, a silent wave. A whisper of possibility that only reveals itself under the right conditions. Reality is not solid, reality is probability. But then something even stranger happens. Something that pushes physics into the realm of the supernatural. Scientists fire electrons one by one, not streams. Just a single particle at a time. One electron, one hit, yet over many attempts, the interference pattern still forms, somehow. Each electron behaves like a wave, passes through both slits, interferes with itself, and lands in a predictable wave pattern. But how? How can a single particle behave as two waves? And then comes the horror. When detectors are placed at the slits to see which path the electron takes, the interference pattern disappears. Just by observing, the wave collapses. The particle chooses a definite path. It behaves like a particle. No interference, no wave behavior. The act of measurement changes the outcome. Reality responds to our observation. This is not philosophy. This is experiment. This is physics. In the halls of early quantum theory, a quiet genius named Erwin Schrödinger introduces a new idea, the wave function, a mathematical representation of all the possible states a particle can exist in. Before observation, a particle exists in a cloud of probabilities like a ghost with many futures. After observation, the cloud collapses into one outcome, one location, one path, one reality. This collapse is one of the greatest unsolved mysteries in science. Why does observation cause it? What counts as an observer? Is consciousness involved? Is the universe watching itself? Quantum mechanics provides the equations, but not the answers. Imagine the particle as a traveler standing before two paths. In the classical world, it must choose one. But in the quantum world, The traveler becomes a wave, occupying all paths at once, exploring all possibilities, living through all futures simultaneously. When you look at it, you force the traveler to choose. You freeze the wave into a single reality. This is wave-particle duality, a dance between possibilities and outcomes, a universe that exists as many until forced to become one. Wave-particle duality hints at a deeper truth. What we call reality is not fixed. It is fluid. It is potential. The universe does not commit to a single story until it must, until something, an interaction, a measurement, an observation, compels it to decide. But the wave is still there, underneath the surface, shaping behavior, influencing outcomes, guiding the future. We do not see the wave, but the universe feels it. This hidden wave, the wave function, is the heartbeat of quantum mechanics. Take a moment, look at your hand. It feels solid, it looks stable, it seems real. But beneath the surface, every electron in your body exists in shimmering probability waves. Your atoms are built on uncertainty. Your thoughts arise from particles that refuse to obey classical logic. You are a creature made of waves and particles, a living interference pattern shaped by the quantum realm. Wave-particle duality is not just a property of light or electrons. It is a property of existence. Even today, the question lingers. Does the universe decide its form based on observation? Is wave-particle duality a fundamental feature or a clue to an even deeper hidden reality? Some theories claim the wave never collapses. Instead, the universe splits, forming parallel worlds for each possible outcome. Others believe hidden variables control the particle's behavior. Some suggest the wave is more real than the particle. But the truth remains elusive. Quantum mechanics gives predictions with unmatched accuracy. Yet the meaning behind those predictions remains shrouded in cosmic mystery. As we peer deeper into the quantum realm, we discover not chaos, but a strange and delicate order. A universe built not from solid blocks, but from shifting probabilities and silent waves. Wave-particle duality is not a glitch. It is the signature of a universe more mysterious, more elegant, and more impossible than we ever imagined. A universe that behaves differently when watched. A universe that hides infinite futures beneath every moment. A universe waiting to be discovered. And in that shimmering boundary between wave and particle, between possibility and reality, lies the true nature of existence. This is the quantum world. This is the hidden architecture of everything. This is wave-particle duality.